Dude, check this out! ASRock has a Radeon 7900 XTX that is completely fanless. This is gonna be great for about 30 seconds. Then it starts to thermal throttle dramatically.
Are you sure you don't remember that?
This was part of the plan. I have always wanted to take one of these server-oriented desktop cards with no fans on them and hook it up to an air conditioner. Get it? AC PC. Not so fast. First, we'll answer the closer look. AC 516S portable smart air conditioner. Our sponsor for this video is Ria. It's a 14,000 BTU model. It's designed to cool up to 450 square feet. So, for a couple of square feet of computer, meaning that when you're done, you will build the first ever gaming PC that actively cools your room.
Well, this is nice and flat, so I think the easiest way to get the air from the PC is going to be just some kind of shroud in the front.
Oh, did someone already do the work for you?
I did.
Wow! Okay. Okay, well, she's not completely airtight for us to get it tested.
Right?
Hey, not bad. Yeah, this is just proof of concept. Glorious. Hey, you know, is that better?
Oh, that's beautiful.
Okay.
So what I'm thinking,
Yeah.
go into the front here, it's like,
Oh my god.
start it up. We just have to prove that it works.
Did it turn on?
Yeah.
Somehow, everything still works. Wow, our CPU is at 16 degrees and our GPU is at 33. And the CPU is up to 32 meters.
Let's pull this out.
You know what's the craziest part of this? Is that the cost of buying a window AC unit actually not that far off, like getting a custom water block system. Like, should we just be ducting chilled air into our systems?
Maybe.
Not necessarily. Spoiler, condensation can be a major issue when you are plumbing cold air directly into a warm environment, but we'll get to that later.
You can just get pretty warm.
It's only at around 70 degrees still.
Okay.
The CPU is sitting at 27 though. What we weren't expecting it to be. What we have found though is that it's not dropping as low or as fast as when we were running without the duct. I want to see what we're going to land at. We're at 100 degrees on the GPU, which is obviously not ideal, but we're at 1500 megahertz. So while we're at the same temperature, we're running at 4x, 5x the clock speed.
Yeah.
That's a pretty good deal. We're settling in around 1400. You can actually see a difference in this movies with the cool ducted air heading right through the heatsink yet. I think this is pretty promising. Let's put some more work in. Now we're going to switch over to the other AC unit that we did back things to.
Oh yeah.
Blocks for 3D scanning.
Exactly.
Wicked smart. Okay, let's have a look.
We also made a little group system. We could do this if I get too cold, it goes up to the pressure.
And we don't want that.
You know, we want to keep running. We want to keep running things on the back. We can do it like
Right?
Yep.
Ooh! Makes sense. The main issue with our mock-up though was not getting the cold air off of the AC unit, it was getting that cold air plumbed up to our components. So that is where these shrouds come in.
So it's on the outside.
Yes.
Air goes in.
Okay.
Air comes out of them. Into the... Okay, so we thought that this little guy here, constant.
Right.
Turns out that's really... Right, and also that's kind of nuts.
Right. Whoa! That's awesome! We're gonna put that cold air right down the fins. Okay. I am a little concerned that the fin density on the GPU is a little bit higher than on the CPU. Yeah. If you had an AC in the unit anyway,
I mean, this is like 14,000 BTU.
yeah.
But what, 4,000 watts? Yeah. Which get too cold when you're not putting on there. Water just run out in the middle.
But it's possible that the system will work even when the AC is not running. Oh dude, I can still get flawless pictures of it. We don't really care if we have any losses of coolness into the room around us anyway.
Well, enough once you see.
Yeah. There she goes. Not gonna lie, I'm still not feeling much out of that GPU, dude. We may need to put some kind of baffle or something in to make sure that we're not sending all of the airflow to the CPU. And that's where something like an insulated duct would come in to make sure that it's still running at optimal efficiency while giving you that sweet, sweet silence. Of course, none of that's going to be very useful if it doesn't work. Oh no. Jordan,
Yeah, but
our CPU is at 17 degrees,
that seems a little cool.
but our GPU is at 90.
Okay.
I think we need to put more baffle in.
Yeah.
The CPU needs like nothing.
Interesting.
Oh, this is so nice. Sorry, computer, I need this more than you right now. We have the hot side blowing at the evaporator. That is to maybe hopefully help keep ice from forming on it. Oh, dude, we're down to 82. Oh, dude, I'm starting to get excited now. Okay, now this is getting cool. 80. We're at 80 now. 76. Dude, every single tiny gap that I plug, we are getting extra performance. Dude, she works awesome. And what's really cool is we're still throwing all this cold air out into our room. Yeah, the air coming off the GPU is actually pretty toasted. I think we would need, like you said, to tweak the baffle system a little bit, or create a less turbulent path for the air into the GPU to try to. But overall, we're still getting cold air off of the back of the system.
Yeah.
Everything that's coming through the CPU is like freaking cold. And RTC, and we have no fans in this thing. Here a little bit. 76. Didn't really make a difference. As direct as possible here. Ooh, I can feel more airflow off the GPU for sure. But it's a lot more. We're down to 74. And we'll be settling around 76. So let's see if we get a little bit more out of it here. This is getting a little down now. Hold on. So you probably want to insulate the whole shebang. Actually, this especially. We're gonna get like condensation dripping off this in the longer term. 71, that's the lowest temp we've seen so far though. So that's an interesting thought. So you'd want insulated lines. Final temperature, a nice 69 degrees, under load in Valheim, and all it cost us was the risk of condensation forming, which is gonna happen anytime you have a cold surface and warm air. So if we were to deploy something like this longer term, we would want to put some kind of insulation on everything from ducting to any 3D printed components, and especially on anywhere inside the system where cold air is going. But with that said, I don't think this is actually that wild of a concept for someone to do at home. If you're going to have the AC anyway, look at these CPU drives. It's sitting at anywhere from 11 to 14 degrees in beams. And it says, what do we have in here? A 12700K. That is flipping awesome. You don't have to use a real AC for this kind of shenanigans. In fact, I'm sure they'd probably prefer if you don't, you just use it to clean your room. But hey, massive shout out to them for sponsoring this video and letting us
Gently abuse their machines, maybe?
yeah.
Not so gently?